Hello everyone, this is Rekha. Today I am going to tell you about Kirchhoff's laws. So Kirchhoff's voltage law, or short form we call it as KVL, states that at any instant the algebraic sum of the voltages around a closed loop or circuit is zero. Or it can also be stated as sum of the EMF and the voltage drops in a closed loop or a circuit is zero. So mathematically we can say that the summation V is equal to 0, or sigma EMFs and the summation of IR drops is equal to 0. So sum of all the EMFs in a circuit and the sum of all voltage drops is equal to 0. So let us take an example with a circuit. So let V be the battery and R1 and R2 be connected to this battery. So let I be the current flowing through this loop. So according to KVL, we can write that V minus IR1 minus IR2 is equal to 0. So V is the EMF in the battery, then IR1 and IR2 are the voltage drops. So we can also write this equation as V is equal to IR1 plus IR2. Now how we have taken this polarity, whether it is plus V or minus IR1 or plus IR2. Okay. For that, let us consider like this. So I consider a battery with EMF V. So if I am moving in this upward direction, that is from negative to positive, then I will take the polarity of V as plus V. So if at all I am moving in downward direction from positive to negative, then I will take the convention of V as minus V. So this is for the voltage source of the battery. Suppose if I have a resistor, I want to take what is the convention for this. Then if the current direction through this R is downwards and I am taking my conventional direction also downwards, okay, then if both the directions are same, then the voltage drop is I minus I into R. Similarly, if it is in the opposite direction, if my movement is upwards and the current direction is downwards, then the voltage drop is just I into R. So this particular law depicts the law of conservation of energy. Now coming to the Kirchhoff's current law, or in short we call this as KCL. So what does Kirchhoff's current law state? So Kirchhoff's current law states that the algebraic sum of all the currents meeting at a junction is 0. So mathematically we can represent Kirchhoff's current law or KCL as algebraic sum of Ij equal to 0, where K is the number of branches meeting at a junction and Ij represents the corresponding branch current. Let us take an example for illustration. Let me consider a junction O where the branches I1, I2, I3, I4 and I5 currents meet. Okay. Now according to KCL, the algebraic sum of all these currents are 0. Also the other way we can state it as the currents which are incoming is equal to the currents outgoing from the junction. So in this network, I1 and I2 and I3, okay, are three currents which are incoming, and I4 and I5 are the currents which are outgoing. So I can write in the form of equation as I1 plus I2 plus I3 equal to I4 plus I5. So incoming currents is equal to outgoing currents. So this particular law depicts the law of conservation of charge. Hope you have understood Kirchhoff's laws. See you in the next video. Thank you.